it is now time to figure out how to use the unit circle. We have this beautiful paper plate with all the values of the unit circle on it, and this little blurb explains why we did what we did. It's a circle centered at the origin with a radius of 1, which is why we're able to do all of the values of our 30, 60, 90, and 45, 45, 90 triangles and all of those ratios. We know that around our unit circle, the coordinate points are representing, that's backwards, cosine of x and sine of x. Wow, hello. This should say cosine of theta, sine of theta. That's bad. That's straight up the wrong definition. But the tangent of theta is sine over cosine. So the reason I have you have the paper plate out, and again, if you're in AP Cal or AP Pre-Cal, you would have to memorize these. But for my class, we're going to use this as a reference for the entire semester, so don't lose it. But if the question asks us to find exact values, specifically the word exact values, we're no longer using our calculator, changing it to radian mode and typing it in, because that won't give us an exact value. And we're actually going to start off with the B question here that says find the exact values of sine of 7 pi over 4. That should say cosine of 7 pi over 4. Wow, that's the second typo already, and we just got started. Cosine of 7 pi over 4 and tangent of 7 pi over 4. So what we're going to do is look at our paper plates. We're going to find the angle, 7 pi over 4. What color is the line that says 7 pi over 4? Pink. That coordinate point at the edge of the pink line says square root 2 over 2, comma, negative square root 2 over 2. Do you see that? Bless you. That means immediately I know that the sine of 7 pi over 4 is negative square root 2 over 2. That the cosine of 7 pi over 4, bless you, is positive square root 2 over 2. And because of the way I had you build your unit circle, you will flip your unit circle over and look at the over 4, the pink lines, why all the colors mattered. What does the back of your unit circle say pi over 4, tangent of pi over 4 is equal to? 1. Now in this quadrant, should tangent be positive or negative? We're in that fourth quadrant, it should be negative, so we know it's negative 1. Boom, the end. You've got all of the exact values out of your unit circle. Isn't that nice? Okay, let's do this again, but this time it says to find sine, cosine, and tangent. Look, it's actually spelled correctly this time. For 3 pi over 2. Okay, we find 3 pi over 2 on our unit circle. Do you find it? What color is the line? Black. Oh, cool. So 270 degrees is 3 pi over 2. The coordinate point on that black line is 0, comma, negative 1, which means I immediately know the answers to everything. I know that the sine of 3 pi over 2, is negative 1. I know that the cosine of 3 pi over 2 is 0. And I know that the tangent is the ratio of sine to cosine. I don't have a hint, a tip, a trick on the back of the unit circle for this, but we have the values written down right here. We have the value of sine, we have the value of cosine, which means the value of tangent would be negative 1 over 0. Do I circle that? Is that my final answer? Thank you for shaking your head. No, what is the actual answer here? Undefined. You cannot divide by 0. So tangent has some undefined moments, which we will see in chapter 4 when we look at the shape of the tangent function on a graph. Okay. Now it can get a little bit more complicated. Like maybe let's say I ask you to find the exact value of tangent of negative 5 pi over 3. Ooh, negative directions are not written on my unit circle. But what can we do instead? My recommendation would be that we count by pi's over 3's. So if I am just grabbing all of the multiples of pi over 3 from my unit circle, I'm going downwards, clockwise. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. All right. So I'm pointing at, on mine, when I get there, at the line that's green that says normally this is pi over 3. Right? Negative 5 pi over 3 goes all the way around to quadrant 1. So if I want the tangent of this line, I will flip it over Boom, look at the green. The solution to tangent of negative 5 pi over 3, which is the same as asking you the tangent of pi over 3. My unit circle says that's square root 3. And it's positive because we're in quadrant 1. Again, it can also get more complicated if maybe I start asking you some of the reciprocal values, like the exact value of cosecant of 2 pi over 3. But if we just remembered that cosecant and sine are reciprocals of each other, I know that the cosecant of 2 pi over 3 is like 1 over the sine of 2 pi over 3. That's a question I can answer on my unit circle. We look on our unit circle for 2 pi over 3. I've located it. It is a green line in quadrant 2. What is the sine value of that coordinate point? Square root 3 over 2. So I have 1 over square root 3 over 2. We reviewed our fraction rules earlier. What's the rule for dividing a fraction? Keep, change, flip. You keep the 1. You change the multiply to divide, you flip the fraction. This becomes 2 over square root 3, but can't do that. We rationalize our denominators. This becomes 2 square root 3 over 3. Say again? Well, what's 1 times 2 over square root 3? 2 over square root 3, yeah. From just this part so far, are there any questions about how I'm going to be asking you to use this unit circle now to find the values? Not yet? I can eventually maybe ask you to use a unit circle backwards. What if I gave you the ratio and asked you to give me the angle? We're going to have to be reading this unit circle backwards, basically doing some inverse trigonometry without doing inverse trig functions because I know there's restrictions on their domain. We will get there later. Part A here says to approximate the value of theta in the interval from 0 to pi over 2 if cosine of theta is equal to 1/2. Ooh, there's a lot of things we need to understand here. This interval from 0 to pi over 2. Which one of the 4 quadrants am I talking about if I only want you to look between 0 and pi over 2? Yeah, Adriana, you're pointing at it. Quadrant 1, right? Because quadrant 1 starts at 0 and ends at 90 degrees, which is pi over 2. Sorry, pi over 2. So all we're looking for is the singular value, the singular angle that would give me an x-coordinate, a cosine coordinate, if you will, of 1/2. Which of the angles in quadrant 1 gives you an x-coordinate of 1/2? Should be pi over 3, right? That green line has an x-coordinate of 1/2. So the cosine coordinate is 1/2. Again, ignoring the fact that inverse trig has domain restrictions. If I asked you the following questions, find the exact value of theta in the interval from pi to 3 pi over 2 if tangent of theta is equal to 1. Okay, first of all, what quadrant am I asking you for an answer from if it's between pi and 3 pi over 2? Yeah, the third quadrant. Because the third quadrant starts at pi and ends at 3 pi over 2. So all I'm looking for in quadrant 3 is the angle that would give me a 1 if I took the tangent of that angle. Tangent's on the back of the paper, so everybody flip your paper plate over. What angle gives me 1? The 45 degree, the pi over 4, yes, which is pink. So what's the pink version of the angle in quadrant 3? 5 pi over 4. So the multiples of the angles on our unit circle, we have specifically colored the same color on purpose. The back of my unit circle, I see that the 1 was pink for pi over 4, but in this quadrant, pink is 5 pi over 4, or 225 degrees. So keep the colors, unless you colored yours differently, keep the colors secure. We should be able to do this. And that, my friends, is the gist of what we're doing today. I just really want you to be able to learn how to use this or have them memorized. So my friends in AP Cal, you can be practicing without looking at your unit circle. But we will get to use this as a reference in this class.